The next presenter has been a person that I've worked very closely with for the last 4 years during my time here at VI Grade. He's somebody that's shown immense patience with a little bit of an impetuous sales guy like myself, but he's also a pretty smart guy, and I'm proud to be able to work with SAE award-winning presenter, Jeff bet me $5 I wouldn't say that, and North American technical specialist, Mr. Scott Bergeon, who's going to walk you through a little bit of the VI-CarRealTime software platform. Scott?
Thanks, Gary. Okay, I'm going to talk for a couple of minutes about the soon-to-be released production version of our simulator-related software called version 2024.1. This is a major release. It's going to come out sometime this fall, maybe about a month from now. I understand that most of the work's done. There's still some work being done on the WorldSim side, and once that's integrated, they'll be able to deliver all the packages together as a release. It supports updated versions of third-party solutions, like all of our versions do. There's a migration that happens there. This is the first version that is officially Windows 11 certified, although I personally can tell you that I've got a Windows 11 laptop and I've been running multiple versions of at least VI-CarRealTime on without any issues. And I also wanted to point out that the NVH simulator's being renamed here to VI-NVH-Sim, I think to distinguish it a little bit from physical simulators versus this pure desktop approach. So the 2024.1 release is a combination of softwares that are mostly related to, but not limited to, running on simulators, and it kind of breaks up into 4 categories, which I'll cover a couple slides on each one, starting with VI-Sim, then I'll talk a little bit about WorldSim, this NVH Sim solution, and then VI-CarRealTime. And these are each individual software packages, but they really are being released in a group for a reason. There's a lot of communication that we work on to make simulators work, where all of these products have to talk to each other, and because of that, it's difficult to release one piece without the others and make all that communication work. So first, when I talk about VI-Sim, it's the software backbone for driving one of our physical products that's also new, that hopefully you had a chance to see here today, the FSS. So VI-Sim is the dedicated motion queuing control interface for the FSS. What you got to experience today, if you did drive that, was sort of prototype software. This upcoming release is the first official release of software designed to support the FSS and all of the queuing and control interfaces that it needs. Another part of VI-Sim is as a bridge to the other solutions. It's the mechanism that gets the interface between the hardware and the software. And VI-Sim has always had a strong relationship with our SoundSim products, SoundSim X. But what's kind of new officially in this release of VI-Sim is a bridge back to NVH Sim when it comes to vibration response, not just sound. Another area where there's significant change in VI-Sim is around the way axis of rotation gets calculated. Prior to this release, you had to go through and set up based off of COG information, pitch center, roll center data that was defined up front. There's some calculation tools to do that, but the relationship back to the model you were running was done in a nebulous way. But in this new release, those parameters get pulled directly out of the vehicle model that you're running. And then there's also a simplified cockpit set of parameters fed through a JSON file to get this analysis set up. So hopefully that's viewed as a strong improvement in the way AOR is calculated. Another area that is significantly new for VI-Sim is around dashboard and virtual reality dashboard. You may have been able to see this on the VR demo. What this allows you to do is take the definition of a dashboard using WorldSim ModKit and integrate it physically into the VR environment, so that while you're in there and looking at the VR response, you've also got a direct view of the dashboard, either virtually, or you can also have through AR an actual physical display representing a dashboard. So those two are both now done in a seamless way, and you can do either or both. It supports all existing layouts that we have, and it's done through the DriveSim user interface. And there's a free mix of visual and physical displays that you can pull together, and you can mix those. Next up is the vehicle mod kit for WorldSim. So in WorldSim, we introduced in this version the ability to build your own vehicle models. You may have seen that also on the VR demonstration, that the interior of the vehicle is part of that experience that gets presented. So there's a process where you go through 3D asset creation through some preferred modeling environment, go through WorldSim ModKit to generate the full Unreal content and refine that property, and then you bring it into the WorldSim environment as an asset to be used on a simulator. So there's a workflow there that didn't exist prior. Obviously, there's a significant improvement in the graphics related to WorldSim in this upcoming release when it comes to lighting and a number of other places, because this is the version that's migrated to Unreal 5. And then, as we showed in the example, there are several head-mounted display options that you can do. This video that I'm showing here is an example that was done on a track, a virtual track in our Udine development area. But the broadcast that you see is what you would expect from the software. And then, of course, what you see in the headset itself is a slightly different thing. And those headset technology continues to improve, but this is kind of representative of what the quality of the broadcast in this Unreal 5 version of WorldSim. Okay, a couple of points on NVH Sim, which is new. There's a fair amount of work that's gone into trying to make modeling for EVs improved. EVs are a challenge because you can have multiple sources, and order tracking is a critical part of that process. There's some RPM auto tracking enhancement algorithms that have been put in. In the pre-processing, there's some orders to extract cursors that help you identify which orders you're going to pull out of the data to process into your NVH models. And then work that can be done around those orders on filter optimization for the extraction itself. And then finally, there are some performance modeling improvements that allow external models to define multiple RPM and load signals that can be used to help drive multiple source responses inside the NVH model. There are also some advances on the analysis and CAE capability. A new feature is a dual FRF capability, which allows you to have a serial stack of FRFs in your NVH model. So an example might be one model that calculates what the body attachment forces are, and then on top of that, transfer functions that capture the body attachment force to response points. So rather than having to bury all of those into one response, you can split them out into individual ones. We have support for doing transfer functions coming out of VA1 SEA toolset from ESI. We've enhanced in it and expanded some change modeling capability to move towards array sound processing. And then there's a new operational path analysis capability for doing road noise decomposition to break out the various sources of road noise. On the sound design side, we've improved portability of QNX sound models so that designs can be taken between systems. And then open sound design tool integration for a couple of different software options there for setting up virtual sounds on the simulator. Of course, 2024.1, as I said, is the backbone for the full spectrum simulator and the integration platform for that. Although we saw it, we have it running here today in prototype, that will be, when that's released, it'll be available to be used. And then finally, a couple of slides on content in CarRealTime, and for anybody that came in and saw the demo that I was giving in the room next door, there are a couple of items there. First, we have much more integrated support of FMU subsystems and ability to take an FMU parameter sets and expose them for doing design studies and other work within CarRealTime itself with improved I/O. Support for setting up initial conditions and the FMU parameters are all available and exposed. Unit conversion is supported. Another feature that you may have seen if you came over is it's a new solution in CarRealTime called a diagnostic tool. And basically what that analysis does is you define off of some standard analysis that you're going to do, similar to an existing fingerprint, but you simultaneously are identifying scalar parameters off of that analysis and threshold levels that you're interested in meeting that you can have pre-set up. So if you build a new model and you want to just validate that this model is appropriate to be used, you can run this diagnostic and it'll report back to you how well you did against all of the metrics that are in that diagnostic. And it can be built off of standard analyses, or you can have your own custom definitions. There's some work done on file-driven event parameter exposures. If you've ever worked with VDFs yourself, we have an event builder tool that you can open up and access, but there's a lot of parameters in there. And sometimes you would like those parameters exposed to you inside the CarRealTime environment when you're submitting jobs. So that can be set up and exposed so that you can do modifications without needing to walk over and build multiple VDFs yourself. There's some improved import capability for subsystems where you can, you've always been able to import a subsystem into CarRealTime. Now you can open up a subsystem and pull in individual subparts of that into a model, so that if you want to leverage an investment you already have in one model into a new model, you can extract information out of it in an easier way. And then finally, there was a lot of work done to help speed up investigation modes. When it comes to setting up the initial files before they get parsed out and run, that process is improved by a factor of about 10. It's much faster to generate those because of some change in the file formats that are being used. We have included exposure of MATLAB parameters into the ability of an investigation mode, similar to like I mentioned earlier, we can do with FMUs. And then finally, we're moved to a standard ASAM MDF file format, which gives improved performance. We can still get at all the old file formats that we used to write out. Res files are still supported, but this MDF format also has a performance improvement on it. So that's it. That kind of characterizes changes for 2024, which will be coming soon. Did I get us back on schedule?
Yes, thank you very much, Scott. Appreciate you.